This video is going to be about thermodynamics and entropy. So there's really two laws of thermodynamics that you need to know for biology. So the first law is that energy can be transferred and transformed, but it can never be created or destroyed. So this first law of thermodynamics is also known as the principle of conservation of energy. So that is telling us that the amount of energy in the universe is constant if it can never be created or destroyed. But even though it's constant, we can still use it to do things, and we can do that through transferring it and transforming it between different kinds of energy. So for example, between potential energy going to kinetic energy when something starts to move, or the energy that's released from a chemical bond, so that potential energy being transformed into energy to do work, and so on and so forth. But it's important to remember that energy will never be created or destroyed. So moving on to the second law of thermodynamics, that law states that every energy transfer or transformation is going to increase the entropy of the universe. So entropy is basically a measure of randomness or disorder. So in order for anything to happen, it has to somehow increase the disorder or the randomness of the universe. So this concept is very useful in biology because we're able to introduce order into biological systems. So for example, cells and membranes and things like that by increasing the disorder of the surroundings. So a good example of this is if we have two phospholipids like this. And then we have water molecules in the middle that are locked into a certain conformation because they're interacting with this hydrophobic interior between these two molecules. So that is limiting the randomness of these molecules. So now if we push these two phospholipids together, so that now that there's no water in between them and all the water is outside, now we've increased the randomness of the surroundings, because now these water molecules aren't constrained by interactions with the hydrophobic interior between these two phospholipids. Now they're free to interact with the hydrophilic heads, or they're free to move away and start interacting with other molecules. So by excluding water molecules from the center of these phospholipids, we've increased the entropy of the surroundings, while at the same time bringing order to this segment of phospholipids. I hope you found this video really helpful. The concepts and information presented in these videos will be true regardless of what biology course you're taking. However, the material we covered in this video is specifically referencing material covered in Campbell Biology's 11th edition. Remember that if you are an enrolled Baylor student, we do offer free tutoring on the first floor of the Sid Richardson building, and you can schedule a free 30-minute appointment to have one-on-one tutoring online, or you can stop by during any of our business hours. For more information about the services we provide, you can go to our website at www.baylor.edu/tutoring. Thank you.